Hello everybody, welcome to a new series of tutorials on oscilloscope and spectrogram from Blue Mangoo. Indeed, this is a new app which has been released recently, so you can find it now on the App Store. So let's start using it. I'm inside AUM. Let's create an audio channel and let's select for that audio channel my headset microphone, and let's disable also the output, otherwise we have a feedback. Okay, let's click on the plus sign. Let's search for Blue Mangoo, and let's choose the oscilloscope, and here we are. So let's go in continuous mode, where you can actually see spectrogram and oscilloscope continuously being updated. So let's start from the top. So we have stereo controls. So the first one, which is selected, is left plus right. What this means is that it is showing an average of the left and right channel. We can change these to have the channels separated, left and right. So you have the left channel at the top and right channel at the bottom. So what we can also do is check the correlation, as it says here, between the left and right channels in a graphical form. In this case, you see only a single line, because the microphone is mono, so the left and right channel are identical. You have also here a knob which allows you to set the duration of what is being captured in milliseconds. Now, to see these working, so let's add another effect. So for example, in this case, the multi-band has effect from Blue Mangoo again. Let's move the oscilloscope below the effect. Let's go inside the band and let's add something to the left and right channel in terms of delay. So in this case, they're definitely different. So let's go inside here. As you can see, you have now a different pictorial format and or graphical representation, because the left and right channels are actually different, and you can see the correlation here is not anymore 100%. So if I was, for example, to bring these down to 0, it will show again a single line. It will show that the correlation is 100%. So now let's remove this, as we don't need it any longer. So next, what I want to show you is let's go back to the left and right channel, like so. I want to show you the selection of the display mode down here. So at the moment we are showing a spectrogram in continuous mode. Continuous mode means that it is constantly capturing through the input. I can also pause the capture and resume it as well. I would actually pause it because I would want, for example, to check some frequency like that. You can click up here, move down, and as you move down you see the notes here and octave which are changing, and therefore you can check the frequency of the note and octave that where you leave the vertical notes, and that is useful if you want to find out exactly what note or frequency that was being played. Additionally, here you have the traditional oscilloscope view, and in the middle you have actually a merged view. So if I click resume, you can see the oscilloscope as well as spectrogram together. Now if I go back to the oscilloscope, you can of course zoom in and out using your fingers. Okay, and of course I forgot to mention, but on the vertical axis you have frequency, and on the horizontal axis you have times in milliseconds in this case, as you can see down here. Now we are in continuous mode. That means that we are in this case, if I resume, constantly checking what is the input through the microphone in this particular case. And as I said, you can choose the different display mode. Another mode is the frequency one, which is quite interesting, and this works better if you have a synth. So let's close this And let's remove the headset and let's add as a audio Uni extension, let's add ISM. Okay, it is loading, and let's connect it to the MIDI keyboard and also show that MIDI keyboard. And let's open it and let's load a template. For example, a pulse wave will do, that's fine. And let's click, let's exit, let's click on hold here, and let's click on the note A. So it's constantly being played. Of course you don't need anything because I don't have anything in the output channel. So as you can see here, you see the fundamental here and all the harmonics for the left and right channel for what the note is that is being played. And for example, again, a better view here, if I show the average, if I was now to check that and I was to move down to the base of, oh, right there in the middle, there you go, it says that we are playing on A57 220 Hertz on the third octave, which is where we are actually at the moment. And again, if I click on here, what you will see on spectrogram and oscilloscope is the waveform with the fundamentals, and at the moment it is hardly moving because it is programmed as an oscilloscope as an application to actually stop the movement when it matches perfectly the frequency which it has in the banks for all the fundamental notes, so which it does through checking the period lengths, etc. So for example, if I was to move left and right by sense, you can see straight away it was moving. Therefore, for example, if I was to press another note like a B, you see it starts to move. Again, if I was to down trying to find that note, I move until it stops. There you go, it stops there. It says B59 third octave. That is what we are playing. So this is another mode which is very useful. It shows you very clearly the oscilloscopes with the fundamental and all the harmonics. It can be extremely helpful. Now the last mode is a trigger mode. Okay, and this very much works. Let's select the oscilloscope like this. This very much select the level by which the signal needs to go above, like a threshold, in order to be captured. So if I set it up to here, it will disappear. If I lower these down, oops, when it goes around the amplitude of that particular note, it actually starts to be displayed. Okay, and if I move it again up, I wait for 3 seconds, it will disappear, will reset the buffer, and then again if I move this down, as soon as enter the threshold, it captures the notes. And look ahead, what it does, it lets you examine the note before and after when you capture it, and that's the beauty of the trigger mode. So that's in a nutshell the oscilloscope and spectrogram from Blue Mangoo. Of course, no sound for this tutorial, but as you can see, it's an extremely useful application, and that I'm sure you can use in your application. So let me show you here where I'm zooming in again until I see exactly that waveform. Okay, and we are in the oscilloscope. Okay, I hope you found this interesting and you can use the oscilloscope in your application. See you next time. Bye.